Dr. Satyendra, am I audible?
Yes, sir.
Dr. Satyendra?
Audible, sir?
Am I audible, sir?
Ah,
Okay, so I think we should start.
we can start.
What is going on? Okay, I welcome to all the participants in this workshop session. Okay, so today's session will be taken by the Mr. Harish. He is the research scholar in our department. His topic is machine learning, the workshop on the machine learning, specifically the artificial neural network. Now, along with the Harish, I will also guide here. Okay, and after that, Harish, there will be the another session. If we will have sufficient time, then there will be the second part of this workshop session, which will be handled by the Dr. Satyan, the organizing secretary of this workshop. So now I will request Mr. Harish to please present the slides and start the session.
Thank you, sir. My slide is visible. So, good afternoon, everyone. Welcome to workshop session on design and optimization of thermal system. These are my contents, starting from introduction of artificial intelligence and machine learning, then brief introduction to artificial neural network, then machine learning activity, and last, so a practical artificial neural network implementation with real data and role of MATLAB in simulation and implementation. Firstly, artificial intelligence is the science and engineering of designing intelligent agents that can think, learn, and act in the real world. For example, some AI system can analyze patient data to predict the risk of developing certain disease. Then machine learning. Machine learning is a subfield of artificial intelligence that focuses on developing algorithms that can learn from the data and improve their performance over time without explicit programming. For example, like as machine learning algorithms are being used to analyze medical images like X-ray, MRIs to detect disease like cancer at earlier stage. Another example, like as machine learning algorithm to identify and filter out spam emails, improving inbox management. Also, Google Maps uses machine learning algorithm to analyze traffic conditions and suggest the fastest route. Here, the subfields are different field of artificial intelligence like machine learning, deep learning, expert system, artificial neural network, genetic algorithm, computer vision, fuzzy logics, robotics. Then these are the steps of the machine learning activity. Starting from understand the type of data in the given input, then explore the data to understand the nature and the quality. Thereafter, explore the relationship amongst the data elements. Then find the potential issues in data. Then after, do the necessary remediation if needed. Then apply pre-processing step. The pre-processing means the normalization of the data. Then once the data is prepared for modeling, then learning tasks start off. Then the data is firstly divided into three parts, that is training, testing, and validation data. In case of supervised case of learning. In the case of supervised learning, we have to know the input and output both the data. Then after we can apply in the supervised case of learning. Then consider different types of models or learning algorithm for selection. These learning algorithm I will tell you in the after hands-on session. Then train the models for the supervised case of learning. What is artificial neural network? Neural network is a computational model inspired by the structure and function of the human brain. It is a core component of machine learning and artificial intelligence used for tasks like pattern recognition, classification, and patterns. Here, the NN structure, that is inputs, hidden layer, and outputs. Inputs are the set of values for which we need to predict the output values, and these are the hidden layer is the intermediate layer of artificial neural located between the input and outputs. The basic structure of the basic structure of the input layer, hidden layer, and output layer. The application of the real world problem, that is classification, predictions. The question is, why use MATLAB for artificial neural network? Because these models are built-in artificial neural network toolbox, graphic user interface, and command line support, easy to data visualization and model training, compatible with real-time data and Simulink. Data set description, these are the types of data used, that is medical, financial, engineering, size, number of features, and target variable. Pre-processing step, that is the normalization, missing values, and handling data. Okay. NN design in MATLAB. Firstly, we select the network type, that is feed forward, pattern recognition, then defining, then after number of neurons, layers, transfer function, and training function. Training the NN models, starting from the training process, forward pass, back propagation. Back propagation is the nothing but to uh, give the output of the result to how can change our the models. That is the values, whatever the data is correct or not correct. Then data is splitting from the training, validation, and testing set. Then after uses the matrix, that is uses the mean square error and coefficient of correlation. If the coefficient correlation of the values is 1, then our data is ideally fit. We are close to very 1, then our data is good. Otherwise, our data is not close to 1, then there is some errors in our data point. Then after plotted the graphs performance, that is regression analysis, training states, then analysis the results, prediction versus actual plots, accuracy and errors, discuss overfitting, underfitting if available in my data, then regression plots. Weights and bias in a neural network, inputs that I have already discussed. Weight are the real values that are attached with each input features, and they convey the importance of that corresponding features in predicting the final output. Bias is the used for shifting the activation function towards the left or right. You can compare these two by intercept in the line equation. Then our summation function. The work of summation function is to bind the weights and input together and calculate their sums. Then activation function. Activation function is used to introduce non-linearity of the models, and bias the prediction outputs. Data reductions in machine learning. In the machine mean square error, we have calculated here, n is the number of data. I have an equation to use the mean square error. N is the number of data point, by as the represent the observed value, and by cap represent the predicted value. Then find out the coefficient of correlation. Here I have an equation, calculation coefficient of correlation, and here use the formula, and we can find out the coefficient of correlation. Then after I will going to start MATLAB for hands-on training. So MATLAB is starting, it will take little bit time to start. So just wait for a minute. Here is the interface of MATLAB. This type of command window will open. Then go to the apps. Then click here right side. Here there is so many models are available in machine learning and deep learning, but we have only using neural network fitting. So I clicking neural network fitting. So it will take some time to start. For using the machine learning model, we need a data set. Here, I have my simulation data for this model. That data I have calculated from the SPN Plus software. So I have a data point already I have. Then I import my data. Left hand side, click import, then import our data point. Here I have no any saved input data, so browse our data, then click here to browse. Then go to the, I have a SPN plus data software here, so I click the SPN data, then open. This type of interface will showing you if you are. Here I have the different type of data of the vapor compression refrigeration system, which I have obtained from the SPN Plus software. First, vary condenser pressure. Here I am varying the condenser pressure like 3 bar, then 3.1, 3.2, and so on. I have varying the condenser pressure. I think my values are showing to all of you. Then second column, compressor work done. How much the compressor is work done. Then third row, heat accepted by the evaporator. Then fourth one, mass flow vary of the refrigerant like 0.1, 0.11, 0.12, 0.13. So I have total 962 data point for the input case. So I select the input because in artificial neural network model I have to import the input model. So we select the input. Here I am selecting the input data set, then import our input data points. So here predictors is showing 962 cross 5. That means 962 data points in 5 columns. Okay. Again I am browsing. Then open. Then import our data. These are the 964 data points. Okay, then imports. Here 962 into 4, that means 962 data points in 4 columns. That is our predictors value. Then responses. So I have only one responses. Go to the browse, then go to the data, open. Here is the coefficient of performance, that is COP, that is our predictors value. So click here, click over it and select all the data point. Then all the data point, that is 963 data points, import here. Okay, click close, then okay. Here in it is 962 observation with 4 features, and output there is 962 observation with 1 feature. Then click to OK. 2-layer feed-forward neural network is sigmoid function. Here in left-hand side, there is this training data set is 70% and validation is 50 and test data 15. These are already inbuilt. We can also change these points with the training data set, validation data set, and test data set. We can change as per the it will depend upon the how much our data. So we have 4 inputs showing 4 input, and layer size we can change because my data is more. So I have changed here layer size. So we can change here 2 data points. Then output is 1. Then go to the training model. So here there is so many models are available. In MATLAB here 3 types of the models are available. First one, that is LM models, then train with Bayesian regularization model, train with scaled conjugate gradient. Then click one by one. I will click and show the what is the result. Then click it. It will take few seconds. Okay. Then here we can see epochs. Epochs is nothing but how many data points have read. So here is values is 39 and target values is 1000. Here the observation, that is mean, square error and coefficient of correlation is showing. In training case there is the 674, that means the 962 to 70%. I think this 674 data points are the training data set. So in that case, the mean square error is 0.0072 and coefficient of correlation, that is very close to 1, that is 0.9949. Then validation, these values are taken by the randomly, that is 144. The mean square error at that case 0.0059 and coefficient of correlation is 0.9955. Then test 144 observation and the mean square error is 0.0083 and coefficient of correlation is 0.9945. Then we go to the regression plots. Here we can see this is the our target. If I click over here, then after the values is showing, these are the my target values and these are the outputs. This is the in case of the training data set. Then the validation data set, this coefficient of correlation is that is 0.99546. Then in case of the test data set, the coefficient of correlation, that is R is equal to 0.99445. And this is the overall correlation of this. Then after we can draw the histogram graph. Histogram is a type of bar graph that visualize the distribution of numerical data. Then we can check the performance. Here we can see The blue color line is saying the training, and green color line is showing the validation, and red color line is showing the test, and dotted line are showing to the best line fit. Then after we can again go to the generate the code for this particular data set, then generate the code. Here these are the codes for the data that I have used my data. Then run. We have to save the code. Okay, this type of the functioning will showing you. Then if I am save my the code, then we can again check the performance like this. Then we can check the regression also. Here is the regression graph, that is the training, validation and test. Then error histograms. Then test. I have no any data for the test, so I am using the output for the test data set. So again we can use the test data set for the output. So I am using 962 cross 1 data point for the test data set. Then so test is completed, then click to OK. These are the additional tests for the results. Like as the mean square error is 0.0072 and 0.9949. That means that our data point is accurate, that is very close to 1. So our algorithm is accurate. I have one more example to show you again. Go to the apps, then go to the neural network fittings. Then import data, then clear to OK. Then go to the browse, because I am not save here the data. Then go to the browse. Here I have saved my data in inlet outlet. Then click to open. Here is the showing my data point. This is the inlet compressor pressure. The data points are the again vapor compression refrigeration system. Inlet compressor temperature. Second row, third columns, that is ambient temperature. Fourth is evaporator temperature, and fifth is condenser temperature. So I am selecting these are the as a input parameters. So I select all these input parameters over here. So here I have a very few data. I mean 40 data point are there. Then imports 40 cross 5 means 30 data points and 5 features. Then go to the output. Then again browse. Click to inlet output ML data, then open. Here, that is refrigeration effect, coefficient of performance, and power consumption. These are my outputs. Previous case, I have only one output, but in that case is different. Here is a more output. We select all the data points. Then go to import selection and import it. Again import. Then click here refrigeration effect, COP and power consumption. Then import. Outlet is 40 data points and 3 features. Then click rows and OK. Then here training data sets. These are the 70%, 15. We can here already change 15 to 14. We can change depend upon the data points. Layer size also we can change. Then run. Train with first last time I have trained with the scaled conjugate gradient. This time I will run train with LM model. So here right hand side, the training already this observation taking the randomly, data division is randomly. In case of training taken 28, validation test for 6 and 6. The mean square error for the training data is 0.0994, and validation in case of mean square is very large. That means our data point is not good. It means that the what is the performing parameters are there is not good. That is why the validation values is more. Then go to the regression plot. Because our data point is not accurate, that is why the point is shifted to top of the sides. Previous case that the data point lies on the blue colors line starting to ending, but in that case there is a shifted data point in one point. That means our data values is not good. Here again we can check the error histograms. Error histogram shifted in right hand side, so that is also not a good result. Then check to performance. Performance also is not good. Then generate codes. These are the codes of the input output parameters which I have taken. We can again export the plot. Here exporting the plot you can use here. So So this is all about from my sides. Code I have not generated. Yeah, there is so many queries, Mr. Rahul. There are so many video tutorials are available in. You can also check from YouTube's how to train our model with MATLAB.
Hello, participants. Am I audible? Hello. Any participants? Kindly reply to me. Am I audible?
Yes, sir. You are audible.
Okay. So there is just some query in the chat box. It's Rahul A. Patil. So Rahul Patil is asking for the code actually. Now let me briefly explain this session. So first, actually, what Harish has discussed, it's brief introduction because machine learning is a very vast area. So we have briefly prepared that. Okay, and specifically that is ANN. Now coming to this MATLAB software actually. So MATLAB means this MATLAB is actually means known, or you can say that it is famous for no code machine learning. Okay. Yes, like in the last, actually, I think all of you have seen that MATLAB generate that code, okay, for your reference purpose. So that code actually you can generate if you have MATLAB. Na? So after means doing means first you will not need the code actually, right? You have just selected all these models. You have selected the data, and then data will go to the models, and then model will give you that results which Harish has shown you, right? And after that, of course, this is a very beautiful part of this MATLAB that after doing the exercise and after generating the result, okay, that MATLAB itself generate that code. Okay, so it means you can get that code. Of course, you can generate means there is a two types of machine learning here currently. Means of course we can generate our own code, or we can use no code techniques. Okay, means in the no code technique means you no need to like the preliminary ideas of the coding, right? You use that steps. Okay, like here we have did with the ANN. So there are several other the models like decision trees, okay, the LSTM methods, and then ANN, then CNN, then the deep learnings you can further extend. So there are several techniques in the MATLABs. Okay, we have taken the ANN as an example how we perform this no code technique, because if we want to prepare the code, that will take another course, okay, the separate course, and there we can discuss how we can generate that code. Okay, so that will actually require a separate session to means the writing your own code. So this is the no code technique where you will no need any preliminary ideas or the knowledge of the coding. Okay, and at last, what the beautiful part of this MATLAB, that it generate that code. So if you want to go with that code, okay, as a reference, you can go with that. Okay, so that code actually I have Harish shown. Harish, can you present again? Let me discuss that code actually, which MATLAB generated. That last one. Can you present that? Let me show you the code actually. Actually, this is the code actually, which actually generated by the MATLAB. This is not the code actually we generated. Okay, we know how to generate the code, but this is the code which is generated by the MATLAB. So what the tasks we have did, na? Like we have taken the data, we have selected the models, okay, and then we have received the result. We have generated the result. So all these steps you can say is simulated in this code. So MATLAB have simulated these steps, okay, in this code. So if you have the idea of the MATLAB, you can go with that. Okay. So where means one by one in these steps, you can understand that what are the steps here. Okay. So you can see here that there are the different things like inlet outlet data. Okay. Inlet data is it X and T. So these are the data where the inlet data. Then we have the training data here. Okay. So what is the training data? Then you have means it has taken the hidden layer size actually, right? So that is also like the MATLAB has generated. Then the fit, okay, how it is going to fit there, means the training data. So here you can see that the setup the division of the data. So if you remember in the initial means the few steps back, there was a options of the training data and the validation data. So what is the training data here? We let us suppose we have 100 data, right? So you want to give 80 data, means from out of 100 we want to use 80 data to train the model. Okay, so that 80 data here, so that is shown here actually, right? That 80 means how many data actually. So whatever the number of data Haris has used in this that model, okay, among that 70% data is actually used for the training purpose, and it is that data we okay means the MATLAB uses that data to generate the models. Okay, and then if you have the models, okay, right, then what is the next steps? We have to validate that model, whether that the results coming out from this model is correct or not, right? So then we have the 30% data which we are going to use to validate our result. So that 30% means here you can see that we have, okay, the like 14 out of 100 is utilized for the validation. Now after generation of the models, okay, that MATLAB has uses, or you can say the ANN has uses that 14 data to validate that model actually. So this is that step. So similarly, now you can there is just the several further steps. Okay, so that MATLAB simulated or generated that code actually. So this is a plus point of this MATLAB, that of course you can get the code also of this model. Okay, and if you have the idea, then you can go with that code, and then you can understand what is happening actually behind the screen. And what I have seen in this, there are several other these no code software like Rapid Miners is there. Now the MATLAB means there is MATLAB recently included this ML technique actually. Earlier there was no such types of technique of the ML, but in their recent editions he added this, and that's why we have planned to explore this to you, because this is a no code machine learning. Because I know that there are the participants from different fields, and sometimes it is very difficult to understand how to generate the codes, or this is a very complex part of these machine learnings, the writing of their own code, right? So here you can find your own solutions. Okay, here you can find that we do not need any the knowledge of the generating the code. Okay, so that is the beautiful part. And at last, what is happening, that we are getting that code. So if you have idea of the code or not, that doesn't matter. You can generate your own code. If you do not know the code, then you can go with the code, and then we can understand what is happening behind the screen. So generally in the software, what happens? We do not generalize, or we do not understand what is happening behind the screen, right? But in this MATLAB, okay, in this MATLAB software, we can go with the code also. So I hope that Rahul can means yeah, Rahul A. Patil. Now is it clear to you all to you, Rahul? Hello, I'm audible, Rahul. Rahul
Yes, sir.
Patil.
Yes, sir. That seems pretty interesting, and I really like that explanation. I will definitely go through it for the no-code techniques, because I am exactly working on the same research on the heat pump. So the same similar data I have found. That's why I'm asking that one. I also want to work on that part of ANN. So if
Okay.
sir in future if I want to contact to regarding this, so can I get some contact or mail ID something? So
Of course. You can just type our name. You can get all the contact details there. Okay.
okay sir. Okay sir. Thank you.
Is it available? But I hope that I think I have answered your queries, and
Yes sir.
if there is any query, then please ask from other participants.
Yes sir. Yes sir. Thank you.
Is there any query from other participants who is working in this machine learning technique? This is a machine learning technique for the thermal systems. It means one of the examples, because there are numerous things and there are lots of things to understand. But what in this short interval of time we can give, we have tried our best to give you. So if you have any query.
Dr.
Okay.
Dinesh,
Yes, sir.
am I
Yes, sir.
audible?
Yes.
Actually,
Yes.
Harish presented in the first problem the data from Aspen Plus, or from where he got this data? The VCR cycle.
One is from experimental, sir, result which we have generated there, and one is from Aspen, which is generated by our BTech students.
No, some data was experimental, and the other was from Aspen, the software company which makes.
Yes, sir. Yes, sir. Yes, sir.
So
One
that
is from
data is
we have
available.
discussed two case study, na? So one is
Okay.
from experimental, because we want to add these things, means how we can generate the data. So there is a means the ways through which we can generate the data, because machine learning needs data, right? Without data, machine
The
learning is
starting
nothing.
point is the data only.
Data, because if you have no data, then machine learning is nothing.
It will not give
So
one.
means the data we can generate from the experiments. Okay, of course, experiments need some time, and there is another technique through which you can generate the data. It is the numerical. So what actually we have tried, we have that's why we have taken these two examples. One is from experimental and one is from numerical, and then we have applied machine learning over the data through this no code technique.
Okay.
Hello, any query? Dr. Sadeh, am I audible?
Yes, sir, you are audible.
So would you like to continue?
Hello.
Yes, Dr. Sadeh.
Hello.
Yes, you are audible.
Yeah. So you asked me something.
Would you like to continue with some more problem?
Divish, at present it will not be possible for me.
Okay, then we can conclude this session here.
Yeah, sure. Please go ahead.
Okay, so now here, if you have any query related to this machine learnings or like no code data, you can email me. Okay, on my email ID. Okay, and we will try our best to give you the ideas of that machine learnings. Okay. Now with this, we will conclude this workshop session here. Okay, and now we will resume our this short-term course tomorrow. Tomorrow there is one session on the first half, and after that we will do our valedictory session, because tomorrow is the fifth day of our short-term course. So once again, I'd like to thanks all the participants. Okay.